Hi, my name is Todd McAlery. I'm the instructor for APS 150, an ethics course for first-year engineering students at the University of Toronto. This is Module 3A on health and safety. The learning objectives for this module are to discuss how ethics relate to safety, health, and the environment, talk about hazards, some statistics and citations, practical considerations for how to reduce these risks, and the precautionary principle. The Professional Engineering Act defines engineering as scientific activities, basically, that relate to the safeguarding of health, property, or the public welfare. And that means that engineers often are the ones responsible for health, safety, and the environment. Managing somebody's safety isn't something that applies to just the current situation. It applies to the future as well. A lot of engineering works are designed to last for hundreds of years or even more. And the life cycle of the design, from conception through construction, long-term operation and maintenance, all needs to be considered with respect to safety of the individuals. For example, when a tall building is built, before it's even built, there's some discussion as to what happens 500 years from now when this building has a foundation that started to crumble and it needs to be taken down. Can it be safely taken down? If so, how? What's the plan for that? And it's designed right into the process before the building is even constructed. There's a lot of different types of health and safety hazards. You may think of safety hazards as poisonous chemicals or something like that, but it's a much broader scope, including machines that could injure a worker, any kind of fall-related incidences down staircases or off scaffolding, from any height. Injuries associated with lifting heavy loads, people straining their backs. There could be injuries related to pressure or sound or vibration, heat or cold, fire, explosion, electrical, chemical, biological. There's a lot of different types of hazards. And the engineer needs to be considering all of these different types of hazards to create a project or a work product that is safe for all concerned. So I'm going to share a few statistics with you. In the United States, I'm talking about the United States because there's more data available, 4,609 workers were killed in 2011. And that statistic is actually not much different than earlier or later years. What that means is if you were to work for 30 years, which most people do, you stand a 1 in 1,000 chance of being killed on the job. That's roughly equivalent to the risk of drowning, dying in a motorcycle accident, or dying from medication errors. It's not a trivial risk. And the sad part about it is that most of the deaths are preventable. The statistics for the most often cited violations of the Occupational Safety and Health Association standards in 2011 included scaffolding and all the things around scaffolding. So people, weren't properly protected by scaffolding, and it resulted in a fall injury. Fall restraints are another way of protecting people from that. There's hazard communication, respiratory protection, control of hazardous energy, usually electricity, and industrial trucking, ladders, electrical systems, and machine guarding systems. And the sad part about this is really none of these are difficult to prevent. And so it's really just a matter then of having systems in place that make sure that these things are prevented, and prevented all the time. So a few practical considerations. There are economical considerations. There's a certain amount of money that it costs to train people on how to do things safely, to buy protective equipment, to put extra steps in the procedure that make sure that people don't get hurt in the course of doing their work. On the flip side, though, if somebody does get hurt, there's lost time due to the injury and rehabilitation, medical monitoring, and even perhaps legal proceedings that can end up costing a whole lot more. So an investment in health and safety is usually a good investment. There are legal aspects of it. There are laws to comply with. The Occupational Health and Safety Act or the Worker Hazardous Materials Information System specify most of what's necessary for most workers to be protected on the job in most circumstances. Many companies that are involved in high-risk businesses go way beyond these statutory requirements to impose their own health and safety requirements for additional protection of their workers. And there are ethical considerations. Employees have an ethical responsibility to their employers to follow the rules, wear your hard hat, wear your safety glasses, wear your hearing protection. Employers have an ethical responsibility to their employees to make sure that they have adequate knowledge, they've got access to the equipment and to the procedures they need to stay safe. The precautionary principle applies to health, safety, and environment. It's a principle that basically states if you're not sure whether something causes harm, you start by assuming that it does until you prove that it doesn't, rather than starting with the assumption that it doesn't until you prove that it does. Now, there have been several cases in the past where drugs like thalidomide were used by members of the public long before there was an awareness that those drugs caused birth defects, and a large number of babies were born for a short period of time with birth defects called thalidomide babies. Since then, drug companies have put lots more time and effort into testing their products before releasing them to the market, and the Food and Drug Administration in the States and similar agencies in Canada have put more time and effort into making sure that the tests are adequately performed before a drug is approved for release to the marketplace. And that's an example of the precautionary principle. So BP, the big oil company, met all of the applicable regulations when they were drilling for oil in the Gulf of Mexico. And yet they still had an issue with a big oil spill that basically resulted in huge volumes of oil bubbling up to the surface of the Gulf of Mexico, washing ashore and causing, an environmental and ecological disaster for a period of years. So was that enough? If they just obeyed the law and did everything they should have, or should they have gone above and beyond the call to put extra secondary containment in place or be prepared in the eventuality of such a problem to control it more before it happens? And if they didn't, well, maybe future offshore drilling platforms could learn from that experience. Those are the sorts of things that engineers deal with on a day-to-day basis when it comes to safety, health, and the environment. So let's go through a case study. Let's presume that a graduate student is conducting some research into a materials fabrication, thin films. Aluminum and tin are the most commonly used metals, but beryllium shows some promise, and they want to test beryllium to see how well it'll work. However, there are some significant concerns over the toxicity of beryllium. And the methods that are normally used to prevent exposure to aluminum and tin are not sufficient to be protective against beryllium dust. So how does this all play out from an engineer's perspective, from an ethical perspective? Well, there are different roles and responsibilities for the student, the supervisor, and the university. The student is responsible for being aware of potential risks of what they're doing, and seeking enough information and guidance from their supervisor and the university to how to understand the problem, read the WHMIS spec sheets on beryllium, figure out exactly what kinds of routes of exposure are the ones of greatest concern, whether it's inhalation, dermal contact, ingestion, and figure out what kind of personal protective equipment is relevant and appropriate. They need to work together with their supervisor to come up with an appropriate health and safety plan to prevent unacceptable exposures. The university should be involved in reviewing that plan and providing any additional support that might be needed to gain additional knowledge if additional knowledge is needed about some material that is currently not very well known. Then procedures will be put in place so that work can be conducted safely, and those procedures involve a bunch of information, some homework, and some training maybe on how to properly put on a respirator, how to make sure it fits, how to test that it's fitting properly. And usually when it comes to the use of hazardous chemicals, there will be a zone that's established as an exclusion zone, and people are not allowed to come into that zone unless they have appropriate training, unless they have the personal protective equipment, and unless they know about the engineering controls that are in place to prevent unacceptable exposures. In most cases like this, some kind of monitoring program will be in place. That monitoring could include indoor air sampling in the working environment to see whether or not there's unacceptable levels of beryllium dust. It could include monitoring of the individual, blood samples to see whether or not they've got beryllium in their blood, or urine samples. The monitoring could also include monitoring of respirators to see if there's an accumulation of beryllium dust in the cartridges of the respirators, etc. And for all of these cases, there should be some level of documentation so that if anything ever needs to be reviewed, then people can pull out a file on it, look at all the samples that have been collected in the monitoring program, look at the procedures that were put in place for safe use with the beryllium, and be able to confirm that all of those procedures were followed. So in summary, health, safety, and the environment can't be ignored. It can't be just taken advantage of, and that was the case decades ago. And now we live in a world with a lot of relic pollution from a day of previous ignorance. There are regulations, statutes, standards, criteria, and other legal requirements, and they must be followed. That may or may not be enough. There is an ethical obligation to be protective over and above any legal obligations, and sometimes that means going above the minimum legal requirements. And these duties are often implemented by engineers. We are responsible for the safety of the public. It's what we do. And that's the end of part 3A.